All right, so the first page is just either positive and negative exponents or just the multiplication of like bases. And then it gradually adds more things to it as you go through the review. So the first one is 3b to the negative third. I chose number 5 here. With these, what I want you to pay attention to is where that negative is attached, all right? That negative 3 exponent has nothing to do with the 3 coefficient, all right? So when you're doing this particular one, you only want to apply the coefficient to that b. So for this one, you will leave the 3 coefficient alone. You will put the negative exponent only for the b, so that will put the b alone in the denominator. And that would be your answer there, 3 over b cubed. As we did more of these, we added combining like bases and then coefficients in front of those as well. And so for something like number 9, you would look at your coefficients. For this one, we have a 4 and everything else just has a 1. And so we're just going to have a 4 there. And then we are going to look at our x's. We have an x to the 4th and an x to the 1st power. So we have x, and we are going to add that 4 and that 1. And then for our y's, we have a y to the 4th and a y to the negative 3rd. So we would have 4 plus negative 3. And so for our final answer for this one, we would have 4 x to the 5th, y to the 1st power. So if you look at page 2, we introduce groups raised to a power as well as groups and division. All right, and so I pulled number 13 and number 21 here on this page. Number 13, if I had something like a fraction to a negative, that's where I would do the reciprocal first. But because I don't, I'm actually just going to take each piece and raise it to that negative 1. And so I'm going to say 2 to the negative 1. U to the negative 1 raised to the negative 1, and then V to the negative 1 raised to the negative 1. And I'm going to simplify these individually. So my negative 1 here puts that into the denominator. Before I do anything here, I want to multiply those because it is a power to a power. And so negative 1 times negative 1 is just U to the positive 1. And then I have, again, a power to a power. So I multiply those. Negative 1 times negative 1 is positive 1. All right, and so then I'm going to finish with U and V remaining on top and 2 on the bottom. Look at the next one. We have group on top, 2x to the negative 1, y to the negative 3, all to the negative 1, over x, y to the negative 4th, x to the negative 1. All right, so if I look at this one, I am going to do the group individually on top first, and then I will worry about combining top to bottom. So for this one, I am going to take everything to that negative 1 power. 2 to the negative 1, x to the negative 1, raised to the negative 1, y to the negative 3, raised to the negative 1. And I'm going to leave my denominator alone for right now. All right. Since I have nothing to combine this 2 with, you can adjust it right now if you want to, or you can wait till we start doing top to bottom. If I am just looking at the top, I can't simplify the 2 anymore at this point. When I start moving things around, then I'll be able to. For this x, I have a negative 1 times a negative 1. So I have x to the positive 1. And for the y, I have a negative 3 times a negative 1. So I have a positive 3. On the bottom, you can go ahead and combine if you want to. So on the bottom, I have an x to the 1 and an x to the negative 1. So I'm going to add those. 1 plus negative 1, that is x to the 0. And then the y, I cannot combine at this point. If you remember, anything to the 0 power is just 1. So I can just change that x to the 0 to a 1. And now I'm going to look at, from top to bottom, what I can simplify. I have a 2 to the negative 1, so that's going to move that down to the denominator. So that 2 is going to move the denominator. I've already simplified my x to the 0. So I'm going to look at my x's. X to the 1, there's nothing it can simplify with. It's a positive, so it's going to stay up there. And then let's look at my y's. For my y's, I have 3 minus a negative 4. 3 minus a negative 4 is the same thing as 3 plus 4. So that's y to the positive 7. So that's going to put it in the numerator. So I end up with xy in the numerator to the 7th for my y and 2 in my denominator. All right. So you're just going to take it a step at a time. Simplify your numerator as much as you can. Simplify your denominator as much as you can. And then compare top to bottom, your like variables from top to bottom. On this page, we started dealing with scientific notation, converting from scientific notation to standard and standard to scientific. So this first one is in standard notation. We want it in scientific notation. So the first thing you want to decide is where your decimal will be. In between what two numbers? In between the 7 and the 2. So right there in between the 7 and the 2. And then I'm going to see how many places I moved it. So how many places did I move it? 5, right? So I want it 7.26. And because it started out a large number, this is going to be a positive 5 in my exponent. The next group wants you to go the other direction. They give it to you in scientific notation. They want it in standard notation. This is a positive exponent, which means I'm going to make this a larger number. So I'm going to take my decimal and I'm going to move it 2 places to the right. So this one would be written as 234 as standard notation. All right, the last thing we did with these is we multiplied and divided them, So look at the last section there. When you multiply, you are going to multiply your numbers that aren't part of the 10, right? So you're going to multiply your 2.5 and your 8. Your 2.5 and your 8. And then you're going to consider your 10s and just look at your exponents. Just look at your exponents. All right, so for 35, we're going to multiply the 2.5 and the 8, right? And don't forget that when you multiply these, that you need to consider where your decimal is when you do these. Multiply them normally, right? So we're just going to get 40 here, 20 here, 1 decimal place, right? So we end up with 20. So we have 20 times, and then we're going to look at our 10s. For our 10s, we have a -2 and a -2. So we're going to say 10 to the -2 plus -2. So that would be 10 to the -4. However, my answer is not scientific notation, all right? Not scientific notation. So I need to move that decimal place 1 because it's larger than 10. It's a positive 1. So my final answer will be 2.0 times 10 to the -3. Division works the same way. With division, I am going to divide my numbers and then use what I know about like bases to subtract my exponents. So to divide this, I'm going to take the 8.4 and I'm going to divide by 4, right? And I will get 2.1. And so 2.1 for that one. And then for my 10s, I have 10 to the 0 divided by 10 to the -1 to the 1. So I'm going to subtract 1. 10 to the 0 minus 1 gives me 10 to the -1. This is scientific notation, so I can leave it. If it weren't, I would correct it.